Welcome back to the deep dive. I was actually looking at the pass rates for the CPMAI exam
Yeah,
recently.
yeah.
Yeah, and really digging into where people actually stumble. And there's this recurring, almost tragic pattern that you see.
Let me guess, they crush the definitions but fail the scenarios.
Exactly. I mean, they memorize the terms perfectly. They can recite the glossary backward and forward, but then they hit the scenario questions, the ones where you actually have to decide what to do in a messy real-world situation, and they just hit a brick wall.
That is the classic trap, isn't it? It's the difference between memorization and application. It is one thing to know what a hammer is, but it's a completely different thing to know when to pick up the hammer versus the screwdriver.
Right, exactly. And nowhere is that trap more dangerous and, frankly, more expensive if you mess it up in the real world than where we are today. We are tackling phase 4, model development.
Absolutely. This is the engine room. This is where the abstract finally becomes concrete.
So, for everyone listening, here is the setup for today. I'm going to play the role of the coach, the one who wants to make sure you understand exactly what the exam is asking and how to hack those tricky scenario questions.
And I will be your boots on the ground expert, the working AI project manager who knows why these things actually matter when, the project budget is actually on the line.
Perfect. And just to set expectations for you, the listener, we are assuming you have already done the reading. We aren't going to define basic terms like what an algorithm is or what a neural network is.
Right. No basic vocabulary today.
We are going to walk through the Phase 4V structure sequentially, task by task, exactly as you need to know it for the exam.
I am ready when you are.
Okay, let's start with the big picture before we get into the weeds. What exactly is Phase 4? Give me the strict definition.
If we need a strict two-sentence definition to anchor us, it is this. Phase 4 is the stage where the AI model is actually built. The modeling technique is selected based on Phase I cognitive requirements, and the model is trained.
Okay, succinct. I like it. And visually, where does this sit in the overall timeline?
To situate the phase, it consumes Phase I requirements and Phase 3 prepared data and produces a trained model ready for Phase V evaluation.
So is the engine room? Inputs come in, model goes out.
Exactly. Think of it like a construction site. Phase I was the blueprint. Phase 3 was gathering all the lumber and bricks and mixing the cement. Phase 4 is the construction crew actually framing the house.
That's a perfect way to view it. And if your blueprint says skyscraper, but your lumber pile says doghouse, Phase 4 is where that disaster actually manifests.
Oh.
It is. And for the exam, candidates need to know the roadmap to navigate that construction site. We have 4 specific task groups we are going to cover today.
And the order is non-negotiable, right?
Totally non-negotiable. We are going to discuss them in the exact order they will be discussed on the exam and the exact order they happen in reality.
All right, lay out the roadmap for us.
First, we have Task Group 1, which is Select Modeling Technique. This is a critical priority group.
Got it.
Second, we have Task Group 2, Generate Model Test Design. That one is high priority.
Okay.
Third is Task Group 3, Model Training and Model Building, which is also high priority. And finally, Task Group 4, Hyperparameter Optimization, which is medium priority.
All right, let's not waste any time. Let's dive straight into that first group. Task Group 1, Select Modeling Technique.
Let's do it.
You mentioned this is critical priority. Why is this section so heavy on the exam? Is it just because there are 5 tasks in it?
It is critical because it contains 5 distinct tasks, yes. But more importantly, from an exam perspective, this is a decision-based area. It is not just recall.
So it's testing judgment.
Exactly. The exam isn't just checking if you know the names of different algorithms. It tests whether candidates can recognize which technique applies to a specific context. It ensures technique selection is grounded in Phase I cognitive requirements, not just tool availability or team familiarity.
So it is about the why, not just the what. Okay, let's unpack the first task in this group. Task 1.1, select cognitive relevant algorithm and modeling technique. What is the PM's responsibility here?
The project manager needs to be working with the technical team to ensure the chosen algorithm matches the cognitive pattern recognition requirements defined in Phase 1.
So if Phase I says we need to recognize faces, we can't pick an algorithm that's designed to predict stock prices.
Broadly, yes. But it gets a little more nuanced. The exam concept here tests the ability to distinguish between choosing a model for convenience versus choosing for fit.
Fit, That is the key word. Let's look at the correct application example from the source material. We have a healthcare scenario.
Right. In this example, we have a healthcare AI project designed to identify anomalous patterns in medical imaging.
So X-rays, MRIs, that sort of thing.
Exactly. Now think about the cognitive requirement there. It is visual pattern recognition. It is about seeing shapes, textures, shadows. So the PM ensures the algorithm is suited to the visual pattern recognition requirements from Phase-Eye and documents this before training.
They aren't just grabbing a random library. They're matching the tool to the specific cognitive job. So what does it look like when this goes wrong? What is the failure mode?
The failure mode in the source is a project team that defaults to a familiar linear model. Maybe that is just what they know how to use.
For the listener who might be a bit rusty on their stats, why is that fatal? Why can't a linear model handle an image?
Because a linear model tries to draw a straight line through data. An X-ray is full of curves and complex spatial relationships. A linear model physically cannot capture those patterns.
So they build it, and what happens?
The failure is realized in Phase V when the model cannot capture necessary nonlinear patterns, forcing a complete rebuild.
That is a nightmare scenario. That is just burning budget. So for the listener, what is the exam tip here?
In scenario questions, a strong answer involves returning to Phase-Eye cognitive requirements when a team tries to choose based on convenience. Convenience is always a trap.
Got it. Convenience is the enemy. Cognitive relevance is the goal. Let's move to task 1.2. Ensemble methods.
Yes, ensemble methods.
Just briefly, in plain English, what are we talking about here?
It is using multiple models together to get a better result. The PM responsibility is identifying when a combination of base models is required to improve prediction stability.
And the exam concept.
Recognizing ensemble methods is a deliberate phase-off me modeling choice, not a panic fix.
Not a panic fix. I feel like there is a story there.
There always is. Let's look at the correct application first. We have a fraud detection project with high variance across customer segments.
Meaning the data is messy and different groups behave differently.
Exactly. So the team selects an ensemble approach in Phase 4 to combine base models. They plan for it from the start.
And the failure mode.
The failure mode is the team that builds a single model, gets poor Phase V results, and then tries to add ensemble methods as a remediation, causing a massive rework cycle.
So they're trying to bandage the wound after the fact. Quick, add more models.
Right, and it breaks everything because the infrastructure wasn't built for it. So the exam tip here is that a strong answer recognizes ensemble methods as a proactive technique selection, not a post hoc fix.
Clear enough. Let's move to task 1.3. Usage of AutoML. This is a hot topic. Everyone wants the easy button.
They do, and that is exactly why the exam tests it. The task name is Usage of AutoML.
What is the PM watching out for here? Why isn't the easy button always the right answer?
The PM responsibility is treating AutoML as a tool that requires governance, specifically regarding explainability.
Explainability. Okay, because if the machine picks the model, do we actually know why it picked it?
Exactly. The exam concept here is that AutoML is a task within selection, not a substitute for the selection process. It must still meet Phase-Eye requirements.
Let's look at the correct application example. This one involves retail.
Right, a retail demand forecasting team. They select AutoML, but verify beforehand that the outputs can be evaluated against Phase-Eye performance values and explainability requirements.
So they put guardrails on the robot before they turn it on. They say, only give me models that we can actually explain to the business.
Precisely. Now compare that to the failure mode. The team uses AutoML without checking Phase-Eye explainability. The platform picks a high-performing black box.
Which sounds great on paper because the accuracy score is high.
Until it is later rejected by compliance in Phase 6 because it cannot explain individual decisions.
Ouch. They save time in Phase 4 only to hit a brick wall in Phase 6.
Exactly. So the exam tip: strong answers verify Phase-Eye trustworthy AI and compliance requirements before letting AutoML run.
Next up, task 1.4, fine-tuning or R-training of pre-trained models. And just a quick note for the listener, R-training is an alias or shorthand for retraining.
Yes. This is obviously huge right now with foundation models.
So what is the PM responsible for here?
The PM responsibility is ensuring the base model is legally and technically sound before tuning begins.
This feels like it connects back to an earlier phase.
It absolutely does. The exam concept here is the critical dependency on Phase 2.
Phase 2, data understanding.
Yes. Phase 2 has that task for assessing pre-trained and third-party models. Phase 4 is where you act on that assessment. Let's look at the correct application.
Okay.
We have a legal document classification project. The team selects fine-tuning, but references the Phase 2 pre-trained and third-party model usage assessment to confirm licensing and data compatibility first.
They checked their homework. They didn't just download something off the internet and hope for the best.
They did. Now the failure mode. The team skips the Phase 2 assessment and discovers during fine-tuning that the base model contains sensitive content, creating a massive compliance risk.
It is the fruit of the poisonous tree. If the base model is tainted, your fine-tuned model is tainted.
Exactly. So the exam tip. Look for the Phase 2 task pre-trained and third-party model usage, meaning licensing, provenance, and privacy, as a prerequisite in correct answers.
Okay, final task in this critical group. Task 1.5. Usage of generative AI.
The topic of the moment.
It is. What is the PM responsibility?
Assessing distinct compliance, transparency, and hallucination risks before selection.
Hallucinations. The model making things up confidently.
Yes. The exam concept is that generative AI is not a magic bullet for open-ended tasks. It has specific Phase I constraints.
Give us the correct application example.
The source cites a financial services customer-facing summarization tool. The PM verifies consistency with Phase I trustworthy AI frameworks and failure mode mitigations, specifically regarding hallucinations before development.
So they're asking what happens when this thing lies before they even build it.
Right. And the failure mode is a regulated healthcare use case where the team selects GenAI without reviewing Phase I requirements. Regulators later flag that outputs cannot be audited or explained.
And in healthcare, if you can't audit it, you can't use it.
Exactly. So the exam tip. Strong answers recognize that generative AI requires verification against Phase I trustworthy AI requirements before selection.
Let's move to the next task group. Task group 2.
Task group 2 is model test and validation design.
This is high priority, but it only has one task.
Correct. But the exam relevance here is huge. Scoring depends on understanding sequencing. Test design must happen before training to ensure evaluation is not improvised or biased.
Task 2.1. Generate model test design. What is the PM's responsibility?
Documenting evaluation metrics, scenarios, and acceptance criteria before the model is built.
Why is that so important? Why not just build the model and then figure out how to measure it?
The exam concept is preventing selection bias by establishing standards independently of results. If you see the results first, you will shape the test to make the model look good.
Moving the goalposts.
Exactly. Let's look at the correct application. We have an AI credit risk project.
High stakes.
Very. The PM completes the design before training, documenting metrics aligned to Phase I acceptable values and defining how the held-out test set will be used.
So the rules of the game are set before kickoff.
Yes. Now the failure mode. The team trains first, looks at the results, and then constructs an evaluation framework. This introduces selection bias because the criteria are shaped by what the model already produced.
So they build a test they know the model can pass.
Precisely. And the exam tip here is very straightforward. If a scenario presents a team training first and designing the test later, it is a failure mode.
That brings us to the next task in this group. Task group 3.
Task group 3 is model training and model building.
Also high priority, and again, just one task.
This is the core execution step. The exam relevance here tests the understanding that training executes against Phase 3 prepared data.
Task 3.1. Model training and model building.
The PM responsibility is executing the selected technique against the prepared training data partition.
What is the catch for the exam?
The exam concept is about boundaries. The quality of the model is bounded by the quality of the data from Phase 3 and the technique selected in Phase 4. Training cannot compensate for upstream gaps.
You cannot train your way out of bad data.
Right. Let's look at the correct application. The team executes training on the training partition only, respecting the test design. After receiving Phase 3 labeled data, the model is then passed to Phase V.
Very disciplined execution and the failure mode.
The team skips Phase 3 and trains on raw, unclean data. They blame the training process for failure, but the root cause is the lack of Phase 3 preparation.
So they blame the algorithm when the real culprit was the data.
Exactly. So the exam tip. If the model fails, the answer usually traces back to Phase 3 data or Phase I requirements, not the mechanics of the training step itself.
Let's move to the final task group. Task group 4.
Task group 4 is hyperparameter optimization.
Medium priority, one task.
Yes. The exam relevance is understanding the purpose. It is to tune performance. It is a supporting task.
Task 4.1. Hyperparameter optimization. First, What is the difference between a parameter and a hyperparameter?
The PM responsibility is systematically adjusting configuration parameters, not learned parameters, to improve performance. The exam concept is distinguishing between training, which is learning parameters, and optimization, which is tuning configuration.
So parameters are what the model learns on its own. Hyperparameters are the knobs we turn to help it learn better.
Exactly. Let's look at the correct application. The team conducts optimization using the validation partition to avoid contaminating the held-out test partition. Once optimal settings are found, the model is retrained with those settings.
So they use a validation set, not the test set.
Right. And the failure mode is implied in the correct example. Using the test partition for optimization would be a failure. It causes data leakage. You are basically letting the model peak at the final exam while it is still studying.
Okay, so exam tip for this one.
Remember that this happens within Phase 4, but the final evaluation happens in Phase V.
Okay, we have walked through the entire roadmap sequentially. Before we sign off, let's summarize the key takeaways for Phase 4.
First, the absolute importance of sequencing. Phase 1 and Phase 3 inputs lead to the Phase 3 build.
Second,
The rule that generate model test design must strictly precede model training.
and the third,
The distinction that hyperparameter optimization, which is tuning, happens in Phase 4, while the formal model evaluation happens in Phase V.
fantastic. That wraps up our deep dive into Phase 4. Remember to stay strictly within the source boundaries for your exam prep. And remember that an AI failure usually has less to do with the code itself and more to do with the decisions made before the coding even started. Keep that in mind as you study.
Good luck with your preparation.
We will see you next time.